So here we are again in processing, and I thought for today we'd have a look at creating our own Instagram filter. So taking an image from the internet and modifying each of the pixels in it and then seeing what we can do. Okay, so let's just sort of scope out the broad sequence for this. So we're going to start here with creating a couple of image containers. So create a source and a destination image. Then in our setup routine, what we're going to do is find an image on the internet. We're also going to create a blank holder for the new version and resize the window to fit the image. Okay. Then we're going to go through our draw loop. In there, what are we going to do? We're going to load the source and destinations images. Then we're going to go through for each pixel in turn, each little dot, each square of the source image. For each pixel in the source image, work out the RGB color values and modify them. Then update the destination image. With those and display it. And that's pretty much it, I think. There's probably more stuff that we can add in later. So let's get started with this. Okay, so we're going to create a couple of these image containers, which are processing image objects. So I'm going to say pimage source and wittily pimage for the destination image. So the one we start with and destination. Okay. And the one which we end up with. So it's complaining that that's not used at the moment. Well, of course it isn't. We've only just started, haven't we? Right, so find an image on the internet, create a blank hold of the new version, resize this so that it fits. So all of that's what we're putting into our setup routine, or procedure, I should say. Okay, so the source image, and we've got a command here which allows us to load an image. It's typically used with one which you're storing locally, but it will cope with going and accessing something on the internet. So here I've used Google Image Search to find Creative Commons licensed images. I've done a search for Grove House. We've got a couple of really quite nice ones here. I'm going to be very happy with this one. So let's grab the location of that image. Copy the image, not copy the image, copy the image address is the thing that matters for this. So we're loading that image, we put that inside string identifier there, and that's going to be our source image. We're not going to change that source image. The destination image we are going to change, but we're going to start with just a blank one of these. So that's going to be created as an image of a certain width. Well, the width of that is going to be the size of the source image. The width of the source image, and the height of that is going to be the height of the source image, and we're going to store that as a set of red, green, blue color values. I have misspelled destination there. Okay, there are other modes for storing all of this color information. Good, forgot my semicolon. You spotted that, I'm sure. Okay. We have got this, so setup typically requires us to say the screen size. If we don't say the screen size, it produces something 100 dots wide by 100 dots tall, which is going to be a bit tiny. There is a nice command here which allows us to resize that. So I'm going to set the size of the surface, as it's called, to, as we have above, the source width and the source height. There we go. And that, I think, is the end of my setup routine. Right, so now we're into the draw loop. So let's get on and do that. Void draw. The first thing I'm going to need to do here is inside this draw loop to get the source and the destination images both loaded. So that's going to be source is going to be loading all the pixels. That's each of the little elements in turn for that. Source load pixels, and then destination dot load pixels, which allows us to refer to each of these in turn, which is going to be important rather than just the image as a whole inside our drawing loop. Okay, so that comes up as a whole long list of pixels. Each of those is one at a time, so it's not coming up as an array as we had with life. This is coming up with just a long list of these. It does this one row at a time, scanning across the screen. So we're going to need to iterate twice over this. So we are going to go with one row at a time. So we're going to have for integer y starting at the top of the screen, y equals 0, and whilst y is less than the source height, I was expecting that to just bring that in, source height. Okay, and then keep increasing y until we get to the source height. So for every row of the image, do something. Within that, sorry, not a semicolon, curly brackets, within each of those rows, we're going to look at each pixel in turn. So for the x coordinate, which is an integer, starting at 0 at the left-hand end, x being less than the source dot width of the image, and then increasing x as we go. What are we going to do? Well, the current location is however many rows we've gone times their width plus wherever we are in that particular row. So I'm going to declare a new variable here. The location loc is equal to the number of rows we're in times the source width. So there's so many pixels in each row of the screen plus the current pixel within the current row, and that gets us one pixel, or the location of one particular pixel. I think that should be absolutely fine. Okay, for each pixel in the source image, work out the red, green and blue values. So we're now going to work out each of those values in turn. So the red is equal to the amount of red in the source image pixels at a particular location in that list, which is what the square brackets gets us. Remember when we were dealing with arrays earlier, I should have said array, by the way. Okay, similar thing going on for the next one. Red, green is equal to the amount of green in the source at pixels at that particular location. And then I can work out the blue as well is equal to the amount of blue in the source pixels at a particular location, the current location. Okay, that's it. So we've abstracted the red, green and blue color values. We can now start modifying them. So what I'm going to do first is work out the average of those three values, which should give us sort of the overall brightness of the image. I'm still inside my repeating loop here, so for each of the pixels in turn we're going to be doing this. And what we're going to have here is a float average, or we could call it brightness, is equal to what you get when you take the red, the green and the blue, you add them all up and divide by the number you have, 3. Strictly speaking, this is the mean of those values, isn't it? There are lots of different averages. Okay. And now, as we said, we're going to modify each of those for each pixel in turn, work out the red, green, blue color values, modify them. So I've worked out the new average here. What I can do now is say that in the same location in my destination image, currently blank, pixels in a particular location, I want that to be equal to a new color value, which is simply going to be the average repeated 3 times. There we go. So that creates a new pixel based on taking that average of the red, green and blue values and mapping that to the new value for red, the new value for green, the new value for blue. And we do that for every pixel in turn. So that's all inside my repeating loop here. Close one bracket, close the next bracket. and that should be okay there. Just a little bit worried about the indentation. Not that that matters in this language. Okay, let's go with that as my indentation. That's a little bit clearer. Okay, next thing, still inside my draw loop here. That's why we've got indentation messed up. Let me see if I can just indent that all in. That's looking a little bit better, isn't it? Oh, and it was because of my bracket being indented. Okay, that's looking a little bit nicer. Right. Update the destination image with those pixels. And this seems to be a thing which you've got to do in processing, is say, okay, now you've worked out the new pixel values, we were going to replace the image, destination image, with those new updated pixels. So I do update pixels. Okay, I was expecting tab to work. I'm going to get used to that. Pixels for each of those. And then all we need to left is to display that on the screen. The command for that is image with the new version, the destination image, not comma not. And I think we are done now. Okay, so just quickly scanning through in case there's anything which is an obvious syntax error. Yeah, you've missed the semicolon there. Okay, I'm reasonably optimistic about this. Let's see what happens when we actually run the code. Okay, wasn't happy about that. Source cannot be resolved to a variable. But I thought I had set that up earlier. Destination. Okay, misspelled source. There we go. All right. Okay, that's the original blank one. And there we have a grayscale image of Grove House, which is different from the colour image that we started on. So we have there the before, and now we've got an after, where we've replaced each of these red, green, blue channels with the same value in each. So we're just mapping that as a grayscale image. So that's it. I'm just going to keep you listening for a little bit longer whilst we make this a little bit more user-friendly than what we've got at the moment. But essentially, we've just created a image filter now. So it would be nice to get that before and after as part of our program here. Well, we've got a way of doing that. Okay, so what I'm going to do is instead of replacing all of the destination pixels, I'm going to only replace some of them. I'm going to replace those that are to the right of where the mouse is at the moment. So what I want to do is actually keep track of the mouse. So if the x coordinate for the pixel is bigger than the current mouse location, then replace the destination pixels with whatever we've just worked out there. Otherwise, just keep it as is. So else, then the destination pixels at that location is going to be equal to whatever the source pixel is at that location. So on the right hand side of the mouse, change it. On the left hand side of the mouse, just keep it exactly as it was, hoping that I've got the right number of matched brackets in there. Let's see how we get on with that now. Okay, I didn't have the right number of brackets, did I? So it's not happy about the number of curly brackets. I've spotted that this one closes this one, but we need another one to close the one above it, which was for each row of the image. So hopefully that's now fixed. Okay, and there we've got our grayscale image. And now as I move my mouse across the screen, you can see that was where we started. We've not changed anything to the right, left of the mouse, and that's where we finished. So we have the before and after versions of that. Okay, so that's a simple grayscale image. There is of course lots more that you can do with this as well. So for instance, if I want to increase the vibrancy of the image, then I can muck around with this here. So I can take the red, let's have two lots of the red, take away the average value, so that will accentuate the amount of red. And I can have 2 times the amount of green, take away the average, and 2 times the amount of blue, take away the average. And with a bit of luck, that should give you more red, more green, more blue, and less of the sort of overall colour of the image. So that should increase the vibrancy of it. Let's run the code, see what we get. Whoa, so much more vivid now. Okay, so we can do the same thing in the other direction, but I'll leave that as an exercise for you. We can start swapping these values over. So if I replace the green values in my destination image, the red values in my destination image with the green, and the green is replaced by the blue, and the blue is replaced by the red in the original image, we should get something really quite freaky out of this. Let's have a look at what that looks like. Okay, that looks nothing like Grove House, so that's just swapping all of the colour values over in some sort of semi-random permutation of where we started. I don't know if that's necessarily any better than what we had to start with. We can increase the amount of one colour at the expense of other colours, so I can take the red and make this a lot warmer. I can take the green and keep that the same, and I can take the blue and make that a lot cooler. So that's 20% more red, 20% less blue, keeping the green as constant. That should give a nice warm glow to the picture. Okay, it doesn't really, I don't think that's what we'd call warm, but it certainly increased the colour temperature from what we had originally. I don't think that's an improvement either, but play with your own images, see what you get. So one more thing that I want to do here whilst we're doing this is if you want to save a copy of one of these things, then we've got code to do that here. So let's just listen out to see whether we actually press a key on the keyboard. If we press a key on the keyboard, then run some code. If the key pressed is equal to the letter S, standing for save, then run some code and just save the current image using the witty and amusing file name myimage.jpg. Sorry, JPG, close quotes, close the bracket, pop a semicolon in at the end there. It would be nice to get some feedback that we have actually done that, so I'm going to print a message out onto the console, which is this black area at the bottom of the screen, to say image, again inside quotes marks, image saved. Close quotes, close bracket, semicolon, close the curly bracket for our if statement, close the other curly bracket for our procedure call. Right, so let's just run that code. Oh, I didn't like that version, did you? So let's see if we take that 1.1, green times 1.1, blue times 0.8, see whether that's any better. Let's have a look at what we get there. No, I don't think as it is, actually. It's definitely different from where we started, but I don't think that's really, a sort of... Oh, perhaps I'm going in the other direction. I'm making these colours brighter. If we make it darker, maybe that will be more interesting. Blue times 1.3. Let's see whether that takes us anywhere better. No, that's actually just increased the amount of blue in the image, so it's actually a cooler image than we started with. That's where we started, that's where we've got to. Anyhow, I wanted to demonstrate the saving thing, so I press the key S and we get a console message to say image saved, and that has indeed saved into the processing directory. I'm going to stop recording now.